Okay, so ating ipagpatuloy kung saan tayo tumigil kanina. Ito yung pinapakita kong isang circuit breaker na medyo malaki ang size niya, at hindi niya maprotektahan yung mga maliliit na alambre na feeders galing sa kanyang load side, no? Itong mga wires, malamang itong pinakamalaki nito ay mga 14 mm, so mga 70 amperes ang ampacity nito, pero ang circuit breaker na ito ay maabot siguro to ng mga 225 ampere trip o 200 ampere trip. So siyempre si 14 mm na feeders ay up to 70 amperes lang ang kaya niya, pero ang protection niya umabot ng mga 200 to 25. So napakadelikado to. Pag na-overload, nagkaroon ng mga leakage current itong mga feeders na ito, ay magkakaroon ka ngayon ng possible overheating of the wires, and masisira yung insulation niya at pwedeng magkaroon ng short circuit later, no? So ang mga solusyon sa ganitong instalasyon dapat ay may panel board ito, no? So may main breaker ka at meron kang branches, at yung branch circuit breakers mo, doon nakakonect dapat itong different smaller feeders na ito. Yan dapat ang tamang paraan para maging safe yung instalasyon mo. Ito, yung gumawa nito, malamang tinipid niya, hindi niya nilagyan ng panel board design. Dapat panel board design, may main breaker with several branches, depende sa dami ng branch circuits. At makita natin, siyempre ill-maintained yung panel, napabayaan na, hindi siya properly at saka hindi rin siya pala NEMA 3R design, no? Makita natin, although meron siyang ganun doon, pero hindi siya yung talagang tamang design ng NEMA 3R o rain tight design na sana hindi pasukin ng tubig itong loob ng switchgear. Pinabayaan din niya na may mga butas, kaya pinapasok talaga ng tubig. Okay, itong picture nito pinapakita lang na kulang ang support itong conduit na ito. Makita mo, natanggal na siya doon sa pagkakabit niya doon sa enclosed circuit breaker, no? So lesson nito, dapat tignan maigi ang support. Malamang dating may support ito pero kulang, ayun, bumagsak na. Ito, this is a service handhole doon sa San Juanico Bridge, no? na obserbahan ko to nung isang pag-inspect doon or pagbisita, at makikita mo rito yung mga splicing na ginawa, pero nag-rewire yata, kasi makita mo may mga electric tape na nilagay dito sa mga pasukan sa conduits, pero ang makita ko, wala itong takip. So that means that many of our technicians are not providing the necessary mechanical protection for our wiring, no? Okay, so exposed siya to, malamang nung dumating yung typhoon Yolanda ay inabot to ng tubig dagat, itong instalasyon na ito. Alam natin na yung San Juanico Bridge ay na-construct pa nung panahon ng martial law, at ito'y isang magandang view or magandang sample ng infrastructure work ng panahon ng martial law. Okay, itong picture nito nagpapakita na meron tayong mga kilowatt-hour meter base where the color-coded wires from the incoming and the outgoing are red and yellow, no? If these are really color-coded, like in the RYB, no, where you have 3-phase 4-wire 400 volts line to line and 230 volts line to neutral service system for dwelling units in residential condos, yung mga high-rise, no? That means na hindi tama ito, no? Kasi ibig sabihin, pag red and yellow yan, 400 volts yan, no? So ang tama dapat nito is, if this is a 230 volt system for every office, you must provide a 220 or 230 volt service for your dwelling unit, not 400 volts as the color coding shows, no. It is dangerous to feed a dwelling unit with 400 volts, no. Okay, even if you say the load is big, no, because chances are the occupants may not be accustomed to knowing or to a 400 volt system, no. Kailangan red and white or yellow and white or blue and white. So in other words, it should be 230 volt service. You can do the balancing in the bus bar, no? In other words, you can connect A to neutral, and then the next one B to neutral, maybe this one C to neutral, and then A to neutral ulit, B to neutral, C to neutral, and so on and so forth to make the balancing of the system. Okay, you will see that this installation, the installer decided to make the top portion of the panels pantay, no. But the problem is, if the area would be prone to flooding, then these lower panels would be the first ones to get reached by the flood water, no. So my suggestion in this kind of installation is to make the center line of the panels as the reference point, no. So taller panels will have a higher top and lower bottom because of their height, no. But on the average, it would be much easier to be reached, no. Not all of them, not like in this case where it is very low for those tall panels. Okay, here makikita natin ang isang circuit breaker, power circuit breaker, malamang draw out type, pwede rin hindi, no. Pero makita mo na it was remodeled, meaning to say the old breaker was replaced, no. I could imagine that the old breaker just fit snugly to this opening, no. So when they upgraded that old breaker into this new breaker, nagkaroon na ngayon ng awang, no. So we must be very careful when we do this upgrading. We have to do some fittings to make or to plug in the space that is already that is created, because the newer breaker usually is a more compact breaker, no. Ito kasing awang na ito could be an entry point of foreign bodies, no, foreign materials or even animals, no. Okay, like in the case of this next slide, as you could see, there is this living being, a rat that went inside to it because there is no cover to it. As you could see, there is also a lot of dirt inside, no, dumi. Mukhang nagutom yung mabait, tumungtong siya sa ground log at kinagat niya yung isang bus, kaya tuloy na kuryente siya. Ito, kita natin, ganun din, wala sigurong takip nga ito, kaya nakapasok itong animal na ito, pusa. Ganda pa naman ng loob ng switchgear ng bus works, no. So meron tayong batas sa Animal Welfare Act, baka pwede tayong makasuhan kung ganito ang itsura ang ating instalasyon. Ito, kita rin natin, wala malamang takip ito, kaya or may takip siya na may awang, pinasok siya ng isang ahas, no, sawa. Yan, nakuryente siya malamang dyan, no. So kailangan lagi nating ugaliin na walang awang, may takip lahat ang ating mga electrical enclosures or electrical panel boards. Okay, this is an old installation in a plant that we have inspected several years ago, and you could see that there are small wires that are connected to the load side of these fuses, no? So again, parang yung kanina na meron kang main breaker at maliliit yung wire sa ilalim, no? Ganito rin to, no? These fuses are quite big. They could be 100 amperes fuse, no? Kasi bayonet type pa siya. pero makita mo ang wires, they are only of the size na 2.0 or 3.5, meaning to say yung maximum ampacity nila could only be 30 amperes. So 30 amperes or even 5.5 na 40 amperes could not be protected by a 100 ampere fuse for overloading. So the solution for this therefore is to replace this with a distribution panel with a main breaker and several branches to feed these small branch circuits. Same with this, nag-improvise yung planta. Meron siyang main breaker, makita mo yan, ginawa niya main bus yung taas niya, and there are these smaller breakers, okay, that feeds different panels. But you would notice that the incoming line would just have the same size of wire as the branch circuit feeders, okay. So in other words, there's a possibility that this could be undersized, or you know, means it's unsafe, no? Okay, must be replaced with a bus bar type installation, no? Meaning or a panel board type, meaning installation with a main breaker and branch circuits. Here you would see installation of generator cables, no? You would see that there is a trench, but the cables coming out of the terminal box of the generator are just simply left exposed to the open with no mechanical protection. Sana man lang nilagyan dito ng, kung hindi man conduits, syempre pwede sanang cable duct, or at the minimum would be a tray, a cable tray type. Okay, here we have a pod-mounted transformer substation. As you could see, the high voltage cables coming out there down below, but you would see the cover of this pod-mounted station hampered by this service and transport, no? The high voltage cables comes here, goes here inside, and then comes out of here. So the comment here is, the remarks is, how come the installer just installed this substation with a little not enough clearance or elbow room from this service entrance or pedestal, no? So in other words, when doing servicing for this substation, you cannot completely open this door of this substation. So there's something wrong with this. Okay, here we would see a step down transformer in an office building where you would see dark colors here or shades, meaning to say the transformer might have been overloaded several times, so it is experiencing overheating, so that this would be the cause, no? So the idea is this door panel, the cabinet panel, or would have been provided with louvers, no? Pahingahan niya, no? Louvers para sana ma-ventilate itong transformer inside the room. Here you would see a welding done in a conduit na pababa, no? I believe this welding done was para ma-avoidan niya magtraha, no? So meron siyang tubo na install. Dapat putulin niya yung tubo to the correct length, tapos lalagyan niya ng thread, no? Pero ang ginawa niya, hindi siya siguro makapag-thread or wala siyang gamit na threading machine. Pinutol na lang niya at winelding niya, no? Ang nangyari tuloy, kinakalawang siya. There is also a possibility na sa loob ng tubo may traces doon ng rough portion, no? So possibility that the wire could also be damaged during the pulling. You know, when inspection would have been done later and the plants would have grown larger, you would no longer be able to notice this wrong improvisation, no? Hindi pati nga yung weldingan, hindi man lang niya pininturahan, no? Okay, here is two enclosures which would differentiate the correct NEMA 3R box or enclosure. On the right side is the correct NEMA 3R, because on the left side mababa yung kanyang kinalalagyan ng hinge. Ito yung hinge niya nandun sa bandang taas, so hindi siya basta pasukin ng tubig. Samantala ito, dito niya nilagay sa baba, so madali siyang pasukin ng tubig ulan. Okay, tapos of course hindi pa maganda siguro pagka finish niya, kaya nga kinakalawang na. Samantalang ito medyo okay pa, no? Here during one inspection in a plant or in a school in Antipolo, Mambugan, no, we were able to see itong conduit elbow na ginamit, no, fitting elbow. No, makita mo yung elbow mismo mas maliit ang diameter niya kaysa yung main pipe. Saan ka na makakita ng ganyan? Siyempre dapat yung tamang pag-install ng elbow, no. Sa ganitong klase papasukan din ng tubig ito, so mapupuno ng tubig dyan sa ilalim, mabababad yung wire or feeder conductors. This is a concrete manhole, and you would see that because there is no drain sa kanyang bottom, naipunan siya tuloy ng tubig, no. You would see that the cables are high voltage because they are individually installed in individual PVC conduits, no. So dapat pag mga concrete manholes, underground manholes, dapat tayong maglagay ng provision for drain. Okay, mag-break ulit tayo.